Computer architecture, data path cycle. The question is, why does data path cycle have huge impact on the performance of the CPU? And here's why. Slower execution. Each instruction takes longer to complete if it takes more clock cycles to transport the data throughout the CPU. For example, from the memory or the register to the processor, which slows down the CPU. Pipeline efficiency. Multiple instructions can be processed simultaneously by modern central processing units, which operates in stages or a pipeline. Long data path cycles causes delays and lower the amount of instructions processed per second by slowing down the pipeline as clock speed and delay. The CPU can operate more quickly the faster the data can flow. The CPU must wait longer to complete tasks when the data route cycle is lengthy, which slows it down. Decreased throughput, through, decreased throughput, sorry. The speed at which data is transferred determines how fast the CPU can process instructions. Fewer instructions, fewer instructions, are processed in a given amount of time when the data route cycle is lengthy. Managing dependencies. The central processing unit must wait if an instruction requires data that is still being processed. Longer data route cycles result in longer wait times and worse performances overall. And this is another question: how does the CPU fetch, decode, and execute instructions? To begin with, how does the CPU fetch? What occurs? Memory provides the CPU with subsequent instruction. How it's going to operate? The CPU retrieves the instruction from memory and enters it in the instruction register, which is the IR, after examining the address in the programming counter. Coming to decoding. The CPU deduces the meaning of the instruction and its necessary action. How it operates. The instructions are divided into sections. These components are interpreted by the control unit, which determine the necessary operation, such as loading, adding, etc. This operation is just this operation is done even in the name and is self-explanatory. To execute the operation, what happens? The CPU performs the operation. For example, the arithmetic logic unit, the ALU, does math or logic, or the CPU access memory to load or store data. After all these operations, the results are saved and the CPU stores the results in its memory or register. In summary, in summary, the CPU fetches an instruction, decodes it to comprehend what to do, and executes the instructions.